continue where we left off last time. We were talking about tokenizing data. And again, one of the common data interchange formats is CSV. That's comma separated value. If you had a CSV file on your machine and you double clicked it, likely it would open up in Excel. Why? Because each record is a row, right? And then each column represents a piece of data in that record. And we call those tokens, right? So for example, if we had one line here where there's me in my office, right? Then each one of those things is a token. Now in C, what we did is we broke that apart using strtoke, which stands for str tokenize, right? It tokenizes and splits up that data string there along some sort of a delimiter. In this case, we said that it's comma separated value. It doesn't have to be. There are TSV files, tab separated value files. If you have some other formatting, for example, user information in a Unix system is stored in a file and it's colon separated, right? There's a colon, 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 and then all of those each are tokens. There are lots of different data formats that use this kind of scheme. The first time that you call it, you provide the string that you want to tokenize. Let's just go over here to the actual code. The string that you want to tokenize along with the delimiter that you want to use. You can go into a while loop here because it returns a pointer to the next token. So here's the first token, here's the second token, third token, fourth token, fifth token, etc. Right? And then finally, when it's done tokenizing, it returns null. So what I want to do is I want to put this into Python Tutor, or the C version of Python Tutor, and show you what it looks like. Let's go ahead and get rid of all of the comments. I've already put those into the notes. So I want to visualize this execution, okay? So let's walk through this and see how it actually works. Yeah, all right, fine. Include stdlib, and we're doing include. I don't know why it's persnickety about the standard library when it's never been persnickety about any of the other libraries, but whatever. Right, let's go ahead and put all of them in there, right? So one thing I want you to observe when we go along here is my string of data changing, right? So next, right? So there, I've loaded up my data. There it is in one big giant string, right? And then I've got my token, all right? So we tokenize it for the first time here, right? And that pointer is now pointing to the first token, CHRAS. Did it change the string? Look real closely. Is something changing? What? This null terminating, that delimiter, the comma, has been changed into a null terminating character. That's how it isolates this one token right here, right? When we tokenize this, we print this out. When we tokenize it a second time, what happens? The pointer advances to the next token, and you'll see that next delimiter has been nulled out, right? The null terminating character, so that you only isolate that one part of the string. Right? Next, 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 next. As we print each one of these out, right? The pointer is changing, changing, changing throughout the entire process. Okay. When we break out of that, tell me about my data. Come on, there we go. Right? Is that the same string that I started out with? Nope. Right? So you got to pay attention to the documentation. Let's go ahead and look at strtoke. Right? strtoke, it takes a string, the thing that you want to tokenize, along with a delimiter. Right? What is noticeably absent with that first argument? No const, right? In other words, I'm not going to promise that I'm going to make changes, but by the lack of this const, I can make changes, and therefore, yeah, by implication, I'm going to be making changes to your data. So if you don't want that, if you want the original data and then you want to tokenize it and do something else with it, then you need to make sure that you're making what kind of a copy? I don't know if we did it in here. A deep copy, right? Well, we did it with respect to arrays, right? If you've got one array and two references to it, that's a shallow copy. Changes via one will affect the other. But if you have two distinct copies, right, then changes to one do not affect the other. So if you want to retain your original data, you need to make a deep copy process that, tokenize that, do whatever you're going to do with that, and then make sure that you're keeping on the original. Did we do a deep string copy function? Yes? No? All right, well, let's do one really quick, right, as an exercise. Right? So what I want to do is I want to create a brand new string that is the same size as the old string and copy over its contents. So deep string copy. Right? It will take a const char star s. Why? Because we're not going to be making changes to the original. We're simply just going to be cloning it, basically. We're going to be making a deep copy of it. And our return value here is going to be char star. Now let's do some error checking, basic error checking here. The only thing that really can go, that we can detect that would go wrong would be that s is going to be null. In which case, what would be a copy of s? Null. Right? That's the only thing that you can return. Right? Otherwise, we'll go ahead and allocate enough space, ... How? By a call to malloc. Char star copy is equal to a call to malloc. Cast the return pointer, malloc. How many bytes do you want? Well, I want size of char because each one of them is going to take however many that bytes and however big the other string is. strlen of s. That looks all right from the perspective of what we've been doing with respect to regular old arrays that hold numbers, right? These don't hold numbers, they hold characters. What's supposed to be at the end of a string in C? The null terminating character. So if you've got HELLO, that's 5, you need to always +1. Is that correct? Mathematically, is that correct? PEMDAS, what should I be doing? I should be parenthesizing this, the first thing in PEMDAS, right? You want 5 characters for hello, +1 for the null terminating character, a total of 6 times however many characters are in that a char takes. Now, technically speaking, this would have worked. Why? Because 99.99% of the time, size of char is going to end up being 1. Right? So +1 times 1, the math works out. That's not good style. Right? Make sure that you are putting parentheses to make it correct math. Return the copy. Did that actually copy anything? Nope, it just set up memory for it. How do I copy one string into another string? Copy equals s. Nope. What would this end up doing? It would end up returning s. And so you would end up having a shallow copy. So you've allocated this memory over here. You've made your pointer point to something else, right? And then now you've leaked out this memory. So that's not how we copy strings. What do? str cpy into copy the contents of s and return copy. Right? I think we provided that in your lab, or maybe we didn't, but certainly you can use this code now, right? Pretty easy. All right, so let's go back to our tokenization of data here, and let's play around with it just a little bit, right? Let's go down here. Right? What I want to do, since I've already copied it over, I'll go ahead and get rid of all this cruft. There we go. All right. What if we played around with different delimiters? For example, what if my delimiter was a 0 instead? Right? What would my tokens now be? Blah, 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 all the way up to there. 0, then 6, then 2, blah, 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 all the way up to the next 0. So let's take a look and see what the tokens are now. Right? Right? Each one of those is a different token. What if I did, I don't know, lowercase m's? Is there only one? No, there are 2. Omaha and, wait, what's the other one? Oh, you know what? Yes, I'm glad I did that. By mistake, early here, I was going to do this anyway. M, that ends up being my first token. You can change the token as you tokenize things along. So if you've got CSV data, but then each token is some subset of data that is delimited by semicolons or something like that, you can go into different modes. You can actually use multiple delimiters. For example, O, comma, and 0. There we go. Now that's not O, comma, and then 0. It is O is a big, capital O will be my delimiter, or commas will be my delimiter, or the number 0 can be my delimiter. Now all three of those are my delimiters, and it will use any one of those three to delimit things. For example, we go from my first name, then the comma, then B, O, U, R, then my last name, then comma, and then we hit a 0, right? So that ends up being a delimiter as well. And we only have 6. That ends up being a delimiter as well, 2, delimiter, and guess what? Delimiter. Was there anything between those two delimiters? Nope. So consequently, did anything get printed? Nope, no token between them. And then it went on to Omaha, then the rest of it, pretty straightforward, okay? So you can have as many delimiters as you want here. What do we do in Java to do this? It's just one function call. You can split it along some delimiter or regular expression. Let's take a look at what this looks like. Right? Let's see, system.out.println. If I just print out the token, actually it's a bad name, right? It's tokens. What it does is it gives you an entire array of strings, each one representing the tokens. I don't know that this will look nice. It doesn't. That's okay. We've got a nice tool called array utilities, right? Just like you were writing a couple weeks ago. Array.toString of tokens. Arrays, excuse me. There we go. Run it, and you can see, there we go. Now those commas are not part of the string. That's its formatting for printing out the tokens. Just as before, what if we went with 0 instead? We would get the same results, right? Now, those commas are part of the tokens themselves, right? What else? What if I did a combination here, like I did with the other example? It doesn't work the same way, right? It doesn't, maybe? Actually, you know what? I don't like this. Let's go ahead and explicitly for string token in tokens. Let's print out 1 to a line, system.out.printf. Token is equal to %s. Again, one trick that I like to do is to surround it with some other value, right? So that I know exactly what's in the string. Because if there's white space in there or something like that, then it's not necessarily apparent if it's at the end of the line, right? And then print the end of the line and then token. There we go. What kind of a for loop did I just use there? And it's an enhanced for loop, a for each loop basically, right? Oops, save it. There we go. There's only one token here, right? That's what it was hard to see. That's why I changed how it was printing stuff out. Why is there only one token? This is not a list of delimiters. It's an actual string. Right? So it's saying, I want my token to be a 0 followed by a comma followed by an O, right? And that's not how it works. In Java, you use regular expressions, which is what I tried to introduce last time, but I failed, right? You can go ahead and put these into a grouping, and now it will use any one of those things to, should. Is it not a regular expression? Let's go ahead and, yeah, it's a regular expression, right? Say what? I'm sure I did that time. Oh, no, I didn't. Okay, I hit the button, but it was just slow? I don't know. Anyway, there we go. Now we get the exact same results as before, right? Now I'm saying that use a 0 or a comma or a capital O as your delimiter, right? And these are regular expressions, right? Except that, guess what? If there's no, it behaves slightly differently from str token C, because between 2 and M, right, there are 2 delimiters, a comma and a capital O. So what do we end up with? An empty token, an empty string, right? How can we test for that? I only want to print it out if it's a non-empty token. If token dot is empty or is blank. I'm not sure. It's true if the string contains empty or contains only white space. And then is empty, is it true if and only if the length is 0, right? So if it's blank, say. If it's not blank, then go ahead and print it out. Right? So you've got all these utility functions that you can use over here, and it's a much richer environment over in Java than it is in C. Right? What took me a manual while loop here and maybe some additional things, it's just one function call here and the use of a regular expression. You can do other things with this, with regular expressions. For example, you can negate it. Anything that is not a 0, a comma, or a capital O, go ahead and use those as your delimiters. And what do you end up with? Exactly the opposite, right? All your delimiters are now in your tokens, right? So you can negate it. You can do things like ranges, for example. Treat 0 through 9 as delimiters. Right? There we go. So any number of 0 through 9s, right? And I think that this will be, 0 or more. We're going to get different, we're going to end up ignoring the numbers, but everything now gets into one single character. Another way of doing that is by doing period and then a star. And, well, nope. Okay, so everything is a delimiter. Anything followed by anything? Can I do that? Nope, that's going to end up being basically everything ends up being your delimiter, right? I think you can leave it empty, and then you can change everything into one big giant character array, right? Now everything is its own character. Right? So you can do a lot here with these regular expressions. Right? They're extremely powerful. Okay. So I'll go ahead and go back to just the comma here so that you can take a look at it in your notes. There we go. So Java. Any questions on this so far? Otherwise, what I wanted to do is I wanted to go back over here to this complex function that we wrote that trimmed leading white space and trimmed trailing white space. Right? First of all, what do you think you do to it in Java? String bar is equal to foo dot. Hey, cool. It's built in. Right? It'll take care of it for you. Right? We had to write our own over here because there is no function like that. But what I wanted to do is, take another approach, take another strategy to this. And to do that, what I want to do is I want to write another function to remove all white space. Or all white space. There we go. Const char. Oh, actually, we'll go ahead and go with char star s. Right? So I'm not going to return anything. You can go ahead and redesign this so that you're returning an error code here and do some error handling. Let's go ahead and do that really quick, I guess. What's the only thing that could go wrong, though? If it's null, right? That's so boring that that should just be the first thing you do, right? Always. Null pointer checks. Return 1, right? Otherwise, at the end, return 0. We're returning those as error codes because you give me a string and I want to take out all the white space. Now, we already observed on Wednesday that if we did this piecemeal, if we said, oh, here's the first white space, move everything down. Here's the second white space, move everything down. Right? If you were processing, say, DNA data, where there are 10 million characters, and half of them are spaces for some reason, right? 5 million of them. You are shifting 10 million characters roughly about 5 million times. We call that 50 quadrillion operations, right? That's going to take hours. Literally, it will take hours or days to do that. We'll benchmark that later on. Right? So instead what we did is, to trim things out, what we did is we counted up the number of white spaces and then just did one shift, right? Likewise, at the end, we started at the end, looked at all the white spaces, and then just cut it off right there. We were only moving things around once. In other words, if we had 10 million things and we had to only switch it out or shift it once, then we only have to do 10 million things instead of, what did I say, 50 quadrillion things, right? Much, much better. But I want to show you even another strategy here of, I don't want to have to think that hard, right? So one way that you can do this is by creating temporary workspace, right? So if I've got the original, H-E-L-L-O, and there are a bunch of spaces in between, right? I don't want to have to worry about shifting things down at all. Instead, what I'm going to do is I'm going to create a temporary string over here. Iterate over this one, and if you see something that's not white space, go ahead and copy it. If you see something that is white space, don't copy it. Right? Go character by character. If you see something that is not white space, copy it. White space, ignore. Copy, copy, copy. Right? Now, this temporary workspace right here has enabled me to not have to worry about those little details, right? Look at how complex this function was. Right? It was correct, it was clever, but is there a better way that we can do it by wasting some space here? We're not wasting space, we're just taking advantage of that extra space. Right? So let's go ahead and create a temporary string to do this for us, char temp. And I'll make it of size 100. Is that a good strategy? No. Will this be able to handle any strings that are more than 99 characters? Nope. All right, make it bigger. Nope. Will this be able to handle any strings that are more than 1,000 characters or more? No, right? It's not an arms race. You can't just keep making it bigger and bigger and bigger, right? If you make it that big, is it even going to run? I don't know how many there are, but let's say that that's 10 megabytes right there. Can you fit that onto the stack space? Nope, Stack Overflow immediately. Our solution is not going to be one that uses static strings, okay? What I want to do is I want enough space here to hold potentially everything. If there was no white space, I'll end up copying everything, right? So if there's, so I want it at least as big as the original string. We know how to do that. We just did it up here. Right? And instead of calling it copy, I'll call it temp. Right? That's big enough to hold the original string s. Right? Okay? Now for, actually, yeah, I'll go ahead and give myself some more room here. For int I equals 0, I is less than, you know what, strlen of s, I plus plus. If you find yourself doing a function call more than once, might want to just put that into a variable so that you only do it once. Right? N and N. There we go. Okay. Now, good compilers will typically, they'll see that you made one function call and another function call on exactly the same inputs. So therefore, I'm going to optimize that and make only one function call for you when I actually, compile it to machine code. A lot of the times they can't do that because if you change the original string, then it doesn't know how big it is anymore, right? So it necessarily needs to call it twice, right? All right, so I'll put that into one variable so that I'm not recalling that function over and over and over again. How do I determine if something is white space? If S of I is white space, ignore it. Otherwise, copy it. Right? Dot, dot, dot. We talked about the, we did talk about it, didn't we? Is space, yeah, it's up there. Other useful functions. I can't do a search. There we go. Other useful things. There's a C-type library in C that has this isSpace function. So let's use it. So if it is a space, ignore it. Otherwise, copy it. So if it's not white space, then copy it. I'll go ahead. There we go. So temp of I is equal to S of I. Does that sound right? I. They move along together here. That's not what I want. I will be moving up here. I want something else to keep track of where I'm copying it, J. So let's create another variable. int j, I'll start it at 0, and then if I copy something over, I will go j++. And I'll use j to do that. At the end of this loop, is temp a valid null terminated string? No. We went up to hello, and then we stopped. We didn't do the null terminating character over here. So let's do that. Temp sub j, remember I'm using this j that's outside of this loop, and it's exactly the value that I want at the end. I'll null terminate it, that manually here. There we go. Excellent. Now, I've only copied over HELLO to this temporary space, right? How does that help me now? I can just simply copy it back into S, whatever was in temp. Okay? Now, am I done? I've successfully copied over everything that is not white space. I've taken this temporary space and put it back into the original. What about this temp space here? It was dynamically allocated. Right? Am I returning it? No. So I'm responsible for it. If I'm responsible for a chunk of memory in this function, what should I be doing to it? To give it back. Free it up. There we go. Now, no memory leaks. If you're going to create, literally, I called it temporary, right? If it's temporary, that means it's not permanent. If it's not permanent, you need to clean up after yourself, right? Okay, that's a good exercise. The last exercise I wanted to do, here, let's go back over here. How do I remove all the white space here? String bar is equal to foo dot remove or replace all. Right? I think we did it last time successfully, didn't we? S with nothing. And system.out.println bar. Right, there. There's the leading white space, the trailing white space are all gone, and in fact, that space between 105 and shore is gone as well. Right? Regular expression. If you only wanted to remove, say, spaces, we would get the same result in this case because I just spaced everything over. This is needed to get all tabs, end line characters, etc. Okay? All right. Questions so far? No? One last exercise maybe? Let's go ahead and go with char. Message. Go Nebraska corn huskers. Right, there we go. So we briefly talked about how to do substrings, right? We did substrings in Java. Where are they? I guess it's down now. Mutable strings, string comparisons. Didn't we do substrings? At least in Java. Maybe later. I know that we did them. Didn't we? Maybe we didn't. I swear we did. Yeah, we did. It's right above string processing. Yeah, there we go. We did this demonstration, right? Where there's a built-in function called substring. Where is it? Right there, substring. In fact, there are two versions of it. You can specify a substring starting at a particular index and then ending at a particular index -1 because it's inclusive, exclusive. Or you can specify one starting value and then it goes all the way to the end. Gee, that seems so useful. I'd really like if there was something like that in C. Right? So if you have a wish like that, go ahead and grant your own wish and write it. Right? So let's go ahead and write one of these functions. In fact, let's go ahead and write this function right here, where it starts at a particular index and goes up to a particular index -1. Right? All right. How did we do that kind of in C? We used a byte limited version here, right? To get a full name, for my full name, I just wanted to isolate Michael here. From index 12 up to index 12 plus 7 plus 1, right? That's how it would work out. So up to 20. The way that I did that is I jumped to the location that I wanted, and then I made that into a pointer to make it point to that string. It might be useful, since we've already got it open here, to take a look at Python Tutor's visualization of this. So let's get rid of this. There's my full name. Right? There's middle name that's uninitialized. I want to, I want to look at this from a different perspective. Let's go ahead and look at these things. So, for example, if I have char initial, right, is equal to full name of 12, right, and then I have a pointer to init is equal to full name of 12. There we go. And now that'll visualize, otherwise it wasn't going to do anything before, right? So this will look interesting. Oh, wow. Did they change it? It used to be the poop emoji. And now they changed it to the death emoji? Huh? I wonder if that's just for Halloween or something. Was it like that the first time I ran it? No?
Oh, like a few minutes ago.
Yeah, it was? Okay, I just didn't notice it. It's never been like that before. Whatever, fine. All right. There's my first name. Now the initial there is going to be M. Why? Because it's referring to this one particular character, right? But if I have a pointer init, initial, and I make it point to that thing, it'll look like this. Now from the perspective of the variable init, it's a string that starts at the capital M and goes all the way to the end here. So that when I do strncpy, what I'm doing is I'm only copying this substring right here. Wow, I can move it. I didn't know that. I wonder if these are brand new features. Okay, if I move it, it goes away. That's not a feature. That seems like a bug, right? What if I rewind it? Will it go back? Yes, it does. Can I move you? How can I move that? Okay, now I can't do it again? How did I do that? I can't believe. All right. It's like Brigadoon. You see it once and it's gone. All right, whatever. Anyway, you get the idea. We've got a pointer here that it points to the middle of a string. So now let's use that idea to write that function. Right? We're going to return a brand new string, right? And I'll call it substring or get substring. Right? And we'll take another string that we're not going to make changes to. So const char star s, int star start and int end. Right? Now remember what this does is this is going to give you a substring starting from start to end -1. Right? We want to match the Java version of this, the behavior there. If you want a different behavior where you're inclusive on both ends, you could do that too. That's what I did in the other two sections. Okay. So first of all, how big is this going to be? Do some error handling on your own if you want to. In fact, that's going to be much more complicated for this one, right? Lots more stuff could go wrong. If s is null, right, or start is less than 0, or end is less than 0, or end or start is greater than the string itself, et cetera, right? So to do more. Right? More. Otherwise, I'll just return null, because that's the only thing that I can return in an error condition. Okay? I'll let you figure out, like, for example, if start and end are reversed, right? That's not valid, et cetera. Right? Okay? So I want a substring starting from start all the way to the end. How big is it going to be? So let's go ahead and go with hello again. Let's get rid of this. We'll just say that we've got some string that starts right here, start. H-E-L-L-O. And so start would be 1, 2, 3, 4, 5. To get 5 And then remember it goes back 1 because minus 1. So based on these two numbers here, start and end, how big would it end, how big of a string do we want to ending up to be, right? New string or new size. How big should it be? Could we do end minus start? Let's put in values for this. Suppose that this is 12. This would end up being 17. 17 minus 12 tells me that it's 5. HELLO. That works. Right? This is why we whiteboard stuff, right? Or a piece of paper or something like that. Right? So let's go ahead and create that new string. Star, char, substring. There we go. That's why I called my function getSubstring. If I'd called my function substring, would it be a good idea to have two things named substring? You get confused really quickly. And then later on, when we start looking at function pointers, even the compiler will get confused if you do the wrong thing. Right? So I like to name all, it's a standard to name all of your functions, verbs, and all of your variables, nouns. So get substring is an action, right? Substring is equal to char star malloc, size of char times new size. That it? HELLO, thing plus 1, why? Null terminating string. Always remember that, right? In fact, if you forget the null terminating string, it might not even manifest itself as an error, or a null terminating character. If you forget to allocate for it, if you forget to put it in, it may or may not even manifest itself as an error unless you're doing something much more complicated, but Valgrind will always detect it, right? So always run Valgrind. So I've created enough space for this. What do I do now? I use what we did before, strncpy into the new substring, starting at s sub start, and we're only going to copy over how many? New size. Okay. And does that take care of the null terminating string for me? HELLO. Did you see the null terminating character in there? Nope. So take care of it. Substring sub new size will be equal to the null terminating character. Why new size? 5, 0, 1, 2, 3, 4, 5. That's why we like 5-letter words. You can hold up a hand, right? and think about your indices. Right? And then finally return the new substring. There we go. Let's test it to make absolutely sure that it works. I want a substring char state is equal to get substring of message starting where? 0, 1, 2, 3. Right? And then going up to and including 4, 5, 6, 7, 8, 9, 10, 11. How many are in there? 3, 8. So 10. So 14? Is that right? System or printf state is equal to %s and the line. And just to make sure, I like surrounding it with pipes here to make sure that I don't have that space in there or anything. Right? Let's run this. I should have, yeah, I was using the wall flag the entire time. Good. Nebraska, ooh, okay. Did I miscount the number of letters? Yeah, my math is off. Nebraska has 8 letters. 3 plus 8 plus 1 is going to be 11. There we go. That's what I want. I just want Nebraska. There we go. Got it. What if I said team? Message. Where would it start then? 12. Cornhuskers. 1, 2, 3, 4, 8, 11 plus 12, so 24. Yeah. Team. Thank you. Hey, we did it, except that I was off by 1. There we go. Right. This is how you should be testing in your hacks, right? You can be a little bit more rigorous about it, right? You know, the state is, I expected Nebraska. Did I get what I wanted, right? And yeah, it works visually. Ad hoc testing, that's all we're looking for. If you want to, you can go ahead and make this a little bit more rigorous, right? And write your own testing framework. If state, strcmp of state and Nebraska is equal to 0, right? String comparison between those two things, right? If it's equal to 0, then it passes. Printf, pass. And the line. Increment your number of tests pass. Otherwise, else, printf, fail. Right? And here you can print out more information, right? This is where I would put out, the state was actually this, but I expected Nebraska. What's going on here, right? So write all of your test cases like we've been doing for everything else. No comment online, it looks like. Just a period. Don't know why. Any other nice exercises? Anything else that you want to see with strings? No? Regular expressions in C. I think you can use them in sprintf. So what I mean by that is, did we talk about sprintf? That you can print to a string? Way down here probably. Yeah, you can print to a string. I think, don't quote me on it, but I think that you can use rudimentary irregular expressions in printf style formatting. Don't quote me on that though. Okay, so again, strings, why do we focus, why do we care about them, right? We're just printing stuff out. No, strings are data, right? Data is what you are processing most of the time, right? Why do we write programs anyway? To process data. How is data represented? Usually as a string of some sort, right? We've already seen one way of doing that using CSV data. Another way of doing that is to use JSON data. There we go. Oops, nope. Let's go ahead and copy paste this data and put it over here, right? That's CSV data, right? It's really common, or really office-oriented kind of data formatting, but there are much better formatting options as far as programmers go, right? For example, JSON. JSON stands for JavaScript Object Notation. This is the same data represented as a JSON, as a JavaScript object. We've got an array here, so we begin with a square bracket. Each element is represented by the square bracket, or the curly brackets representing an object, JavaScript object notation. They're delimited by a comma. Inside of it, we've got key value pairs. So for example, first maps to Chris, last maps to Burke, right? NUID maps to a number. So if it's a string, we delimit it with double quotes. If it's a number, we just use it as a number. Right? Another way of representing data is an older school way of doing it, but still very, very popular, is XML. So let me go ahead and convert it. Oh, it's already been converted. Okay, there. So XML uses what are called semantic tags. So for example, I wouldn't call it root here. I would generally call it people or persons, right? And then here's another person, right? And that ends a person. It's hierarchical, right? You can view this thing as a tree. At the top, you've got your root element. Well, these are all the persons. Within that, you've got tags that an opening tag delimits that everything between this and the closing tag of person is one logical person. We've got opening and closing tags to denote the first name, last name, et cetera, et cetera. Right? In other words, we're giving semantic, in both of these things, we're giving semantic meaning to each record. There was semantic meaning with respect to the CSV data, but it was all located in the first line, right? Kind of like an Excel file. Right? But these are data interchange formats, CSV XML or JSON, right? It's one way for one computer that's in one technology to transfer data to another computer in an interoperable format. This is why it's called EDI, electronic data interchange, right? So that computers can talk to each other in a universal format with respect to data. Right? Then you can even make what are called schemas for these things, where you are creating a definition of your data. And this is the definition, and then you can even say that this data conforms to that definition or it doesn't conform to that definition, and therefore it's invalid. Right? With a CSV file, there's nothing stopping me from just typing a bunch of garbage and crap, right? I could put a bunch of commas everywhere, and it's not going to make much sense, right? What? Your F first, just last, blah, 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 right? The formatting, unless it's followed to a T, you run the risk of malformed data. Right? Even over here with the CSV example here, right? We went through a while loop here, token, 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 token. If it was malformed data, and we 1, 2, 3, 4, 5, 6, we expected 6 tokens, but we had 7, or we only had 5, right? We need to add some code here to do some validation, from some error checking on our data, not just our code. Right? At which point, forget everything, right? Bring in a library to do it. Getting CSV is actually very, very hard. It's simple data format, but even a simple data format has a lot of rules, exceptions, and gotchas. For example, I can't use a comma here in my data. I would necessarily have to escape it. Okay, now you have to escape. Oh, wait, how do I know the difference between a backslash is in your data and this backslash is escaping something? Right? Over here in Java, what did we have to do? We had to escape the backslash, right? So if you want a backslash backslash, guess what? You're escaping 2 of them and doing it twice, right? So it's this never-ending, headache of getting things exactly right. Don't worry about it. Bring in a library to do it. Right? Unless, of course, you're told you can't bring in a library to do it because it's your assignment or something. All right, any questions? Otherwise, what we'll do on Monday is start processing actual files, right? This stuff is not stored in a string. This stuff would be stored in some file somewhere. We need to open up that file, process it line by line to process the CSV data, right? And then maybe even do file output. We're not going to do it because it's way too complicated, but we could read in CSV data and output a bunch of JSON data, right? Convert things, input files, output files. You actually know how to do all of this already because you know how to use printf, right? You know how to use scanf. You just use those on files instead. We're not going to use scanf on files. We're going to use something else, right? But file output is easy. Instead of printf, you use fprintf. What do you think the F stands for? File. Print it to a file. Right? You're done. All right. I'll have a good weekend.